Good evening, dear students. Is the screen visible and am I audible? Okay, fine. So, yes. So today we are going to start with the next chapter, okay, in the chemistry, that is metals and non-metals, okay. So, let us start with the chapter metals and non-metals. So, did you, everybody have seen the periodic table? Yes. Has everyone seen the periodic table? Yes. So, how many elements are there in the periodic table? So, there are how many elements in the periodic table? Yes, you can give your answers in the comment. How many elements are there in the periodic table? How many elements are there? Yes, there are 100 and there are 119 elements up to date. Okay, there are 119 elements in the periodic table. Now this elements, okay, so these elements, so there are different elements, okay, in the periodic table. So these elements, they can be classified into two types. Okay, mainly they are classified into two types. One is the metals, another is the non-metals. So so these metals and non-metals, okay, how they are differentiated or how they are, you can say categorized, okay, based on their properties, okay, on their properties. So there are two properties which we are going to see, okay. Generally what we see, one is a physical property. What do you mean by physical property? Physical property means what? The physical appearance, right? The physical appearance of that particular substance or that particular element, right? And the another is the chemical property. What do you mean by chemical property? Chemical property means how it reacts, okay, how it reacts with the other substances, okay. So that how it reacts with the other substances. So metals and non-metals. So these are the two important categories, okay. So where these metals and non-metals are used. So most of the metals, okay, when you see the, yes, we were discussing about the periodic table. So when you see the periodic table, okay, in to your left hand side, okay, to your left hand side of the periodic table, you have the metals, okay. So that is your S block elements. It starts with your S block element, that is your alkali and alkaline earth metals. Okay, so they consist of your metals. And when you go to your right hand side, okay, so then there will be your non-metals. And in between the metals and non-metals, in the, okay, they are the metalloids. Okay, they are the metalloids. What are metalloids? They act both as metals and non-metals. So these are the categories of these elements. So there are 119 elements in the periodic table, and these elements, how they are differentiated or how they are categorized, they are categorized based on their two types of properties. That is the physical means how they appear, okay. You can say the melting point, the boiling point, okay, the physical state. Which are the physical state? Like they are solid, liquid, or gaseous. Okay, what is the color? What is the smell? So these are the physical properties. What is the volume? What is the density? Right. So these are the physical properties. What is the chemical properties? How they react? Okay. When the substance is kept in atmosphere there is air, right? In air, what is present? Oxygen is present, right? Then if it then again okay, there is moisture is nothing but water. So how the metals and non-metals, they react with these different chemical okay, these chemical reactions. So that all things we are going to discuss in our today's topic. So let us start with the topic metals and non-metals, okay. So yes, so these are some of the metals and non-metals. So you to your left hand side, okay, to your left hand side. So these are the metals. Okay, so these are the metals. So which are the different metals? Okay, which are the elements which come under metals? Platinum, copper, iron, gold. Okay, so these are all metals. So these are few examples. I have listed out few examples of metals. What are non-metals? Okay, what are the non-metals? So that is carbon. Okay, carbon is the non-metal, sulfur and red phosphorus. So these are few examples of non-metal. Okay, so how we are categorize the metals and non-metals? Based on their properties, right? Based on their physical properties and their chemical properties. So so just now we said that how they are categorized, the metals and non-metals on their physical and chemical properties. So let us see the physical properties. So what are the physical properties of metals? Okay, what are physical properties of metals? Firstly, they are having luster. Okay, metallic luster. What do you mean by luster? Okay, the shining surface. Okay, the shiny surface, the metals shine. Okay, they will shine. So how they shine? Because they have that property. Okay, they have that property to show the shiny, sir. Okay, shining. They have that shining property. Okay, so if you take the metals, okay, now we have seen which are the different metals. For example, the copper, silver, gold, and iron. Okay, if you take these metals and if you clean the surface of these metals with the sandpaper, okay, then you can see that the surface will shine. Okay, the surface, it starts to shine. You can see in the photo down, right? In the image below, you can see how the gold, okay, when you see gold, silver, okay, how they have the shine, the copper, okay, in your home, you might have copper vessels, right? Silver, okay, silver articles may be there, then gold ornaments, okay, how they have the shiny surface. So because they are having the property called as luster. Okay, they are having the property of luster. What do you mean by luster? Luster means shining surface. Okay, so metal has that property of shining. Okay, so this property it is called as metallic luster. So this is the one first property of metals. Okay, remember that because the metals are having the shiny surface. Okay, so they are called as the luster property. Okay, this property is called as the metallic luster. So remember that how they are different from non-metals. Okay, so because metals are having the shiny property. Then second is hardness. Okay, second is hardness. These metals are hard. They are very hard. Okay, if you see this, okay, if you take if copper, okay, any copper vessel or any gold, okay, or if you take a iron rod, okay, if you take a iron rod and try to bend it, okay, is it possible to cut it or to bend it? No, right? Because metals are generally very hard. Okay, they are very hard. You cannot cut it with the knife. So if you try to cut it with a knife, okay, it is not possible for the metals, okay, to be cut by knife. So they are very hard. So this is a second property that metals are having hard. Okay, they are very hard. Then these hardness of the metal, okay, it will depend with metal to metal. Okay, it differs with metal to metal. Iron will iron might be very hard as compared to gold. Okay, so the hardness of the metal, it can vary from metal to metal. Then when you see sodium is what? It comes under what type? It is a metal. In which group it will come? It comes under, if you see the periodic table, okay, it comes under alkali, that is in your S block elements. Okay, in S block, you have two groups. One is alkali metals, another is the alkaline earth metals. So sodium comes under alkali metals. So generally, sodium is a soft metal. Okay, it is a very soft metal and it is stored in what? Yes, anybody knows where sodium is stored? Where sodium is stored? Yes, try to answer where sodium is stored. It is stored in what? It is stored in Yes, it is stored in kerosene. Okay, why it is stored in kerosene? Because sodium is highly reactive. Okay, it is very highly reactive to the atmosphere. Okay, to the oxygen, to the water. It will catch fire. Okay, it may catch fire. So sodium, where it is kept under kerosene. Okay, kerosene. In kerosene jar, the sodium is preserved. Okay, because it reacts with the air or the moisture present in the atmosphere and it may catch fire. Okay, so sodium is kept in kerosene. So this sodium metal, it is very soft and it with the help of the knife, okay, with the help of the knife, it can be cut. Okay, it can be easily, you can cut it. So this is a exception. Okay, so sodium it is a metal, but it is an exception where it is very soft. Okay, so we have seen two physical properties, how metals are having a shiny surface. That property is called as what? It is called as the luster property. Okay, the property is called as what? It is called as the metallic luster property. And secondly, how it is hard. Okay, metals are very hard. So this hardness will differ from one metal to another. Next property. Okay, is it clear up to here? Is it clear? So we have seen two main properties, that is metallic luster. What do you mean by metallic luster? The shiny. Why the metals are having the shiny surface? Why? Because metals are having the property called lustrous property. Okay, so because of the lustrous property, the metals are having the that is it shows the lustrous property. Okay, it will have the shiny surface. Then second one was hardness. Okay, next property is malleability. Next is what? Malleability. What do you mean by malleability? Malleability means the metals. Okay, you can see in the image given below, right? They are converted into, you can see they are converted into thin sheets, right? You can see the thin sheets here, right? So what is done here? The metal. So the metal here is in the rough surface. Okay, the metal is in the rough surface. After using the hammer or any other physical, okay, by using what it is done, it is converted into thin sheets. Okay, you might have seen the best example, iron. Okay, iron, you have those iron sheets, right? They use these iron sheets or the also the aluminum sheets. Okay, so why the iron sheets are used? To cover the roof of the house, right? So so what is malleability? It is the property of the metals so that it can be converted into thin sheets. Okay, they are converted into thin sheets. Remember this, very important. Malleability means the property of the metals where it can be converted into thin sheets, okay, in the form of sheets. Okay, so what are the best example of malleability? Which are the metals? Gold and silver. Okay, gold and silver are the most malleable metals. So remember this example. So don't get confused between the malleability. Next is the ductility. Okay, what do you mean by ductility? The next property, ductility, it is the ability of the metals, okay, where it can be converted into thin wires. Okay, you can see the copper wire, where this copper wire is used in the electricity, right? For the electrical, when you give the electrical connection, right? The wires are used, right? Electrical wires are used. So inside the electrical wires, so outside the it will be having the rubber coating, right? It will be red, it will be blue color, yellow color, right? So green color. So like this, the rubber coating, it will be there to the electrical wires. But if you see inside that rubber coating, what will be there? Copper wire will be there, right? What will be there? Thin copper wire will be there. So what is ductility? It is the ability of the metals. It can be converted into thin wire. So the best example is what? Copper. So copper metal, it is converted into thin wires, and where it is used for the electrical works, right? For the electrical works, this is used. So metals are having this unique property. So because of this unique property, okay, so these metals are so the elements are categorized into metals. Okay, so which all property we have seen? First is the metallic luster. Okay, that is the shiny, that is they are having the shine. Okay, they have the shining surface. So that is metallic luster. Second is hardness. Metals are hard. Third one is malleability. What do you mean by malleability? That is they are converted into thin sheets. Okay, they are converted into what? Thin sheets. Then next property is ductility. Next property is ductility. What do you mean by ductility? They are converted into thin wires. Okay. Gold. Gold is also the most ductile metal. So where for the ornaments in the form of chains, right? Gold is converted into thin wires. So metals, because of this malleability and ductility, you can see that the metals can be converted into different shapes, right? It can be converted into different shapes. Like for example, your nail, okay, like your nail, then like your this what different shapes are given, like your wire, okay, in the form of this. So because of the unique property like malleability and ductility, these metals can be converted into different shape. So we have discussed the four important physical properties. Okay, we have discussed the four important physical properties. Okay, let us go for the next one. Yes. Okay. So next is they are good conductors of heat and electricity. Next property, next physical property is they are good conductors of heat and electricity. Okay. So metals. So metals are generally what? They are good conductor of heat and electricity. So because of this, in the electric wires, okay, what is there in electric wire? The copper is there, right? Copper and aluminum will be present. So because copper and aluminum, right? The metals like copper and aluminum, as they are good conductors. Okay, you will not get shock or you will not get any heat this, right? So you mean you'll not get any electric shock or something. So because of that, for electric purpose, okay, in your for your electrical connection and all, okay, what is used? Copper and aluminum is used. Okay, because these metals are what? They are good conductors of heat and electricity. Okay, because of that, in your household or in the commercial sites everywhere, okay, in the electrical wires, which are the metals present? Copper and aluminum. So again, one property, what metals has the unique property, that is conduction of heat and electricity. So they are very good conductors of heat and electricity. Okay. Next is metals have high melting point. So generally these metals, okay, they are having high melting point. Okay, high melting point. So so this is another this. Then which are the best conductors of heat? Silver and copper. Okay, silver and copper, remember this, very important. Silver and copper, they are the good conductors of heat, and lead and mercury, they are the poor conductors of heat. Okay, lead and copper, they are the poor conductors of heat. So this is the property of conduction. Okay, is it clear? So the next property what we have discussed is they are the good conductors of heat and electricity. So because uh, so in the electrical circuits and all, okay, copper is used so that it can so there is no any harm, right, for the people. So because of that, these metals like copper, aluminum, okay, etc., they are the good conductors of heat and electricity. Understood? So this is about the conduction. Okay. So remember that. So what all things we have seen? What are the properties of metals? Metallic luster, hardness, right? So because of that, why the elements are categorized into metals? Because metals are having shiny surface, that is, they are having the metallic luster. Metals are hard, right? Third one is what? They are having the property of malleability. That is, they are converted into thin sheets. Then they are converted into thin wires. That is, the property is called as ductility. Then they are good conductors of heat and electricity. Right. So these are the five properties which we have discussed. Next is sonority. Okay, next is sonority. What do you mean by sonority, students? Yes, anybody? What do you mean by sonority? What do you mean by sonority? They produce sound. Okay. Now metals. Suppose in your this also in your home. Okay. If you bang the metal surface, okay, you will get a sound when you strike. Okay. If you just what strike the hard surface. Okay. What will happen? The sound will be produced. Okay. So sonority is what? It is the ability to produce sound. Okay, it is the ability to produce sound when you strike the hard surface. So when you hit a hard surface, okay, of the metal, then sound is produced. So this ability to produce sound, okay, it is called as sonority. So metals, they are sonorous. Okay, because one example is bell. Okay, you have seen bell. So in the temples, right? In the temples, bell is there, right? So when you hit the this, right? So like this, the bell will be there. Okay, so when you hit it, okay, so what happens? Sound is produced, right? So that is a metal, right? Copper metal. It will be of copper or bronze like it will be, right? So these metals, they are what? They are sonorous. Why? They are having the ability to produce sound when you strike on them, right? So bell. So best example is bell. So bells are sonorous. Okay, metals are sonorous. So because of the property of sonorous, bells are used. Okay, fine. So we have seen 6 different properties. Now, next is the physical properties of non-metals. So we have seen important physical properties. So 6 important properties we have seen. Now, next, let us see of non-metals. Okay, next is of non-metals. So there are, which are the different non-metals? Carbon, sulfur, phosphorus, oxygen, iodine, hydrogen, right? So these are all your non-metals, right? To your right-hand side, when you see the periodic table, to the right-hand side, whatever the elements are present, these are all what? These are all non-metals, right? So these non-metals are few in number. Okay. These non-metals, they are solid or gases. So they are except the bromine. Okay. Bromine is a liquid. So except this bromine, rest all the metals are solid or gases. Okay. Now let us see some of the important elements. Okay. That is graphite. Graphite is what? It is a allotrope of carbon. Right. So graphite is a allotrope of carbon. Graphite, where it is used in the pencil, lead pencil, right? In the lead pencil, graphite is used. So as we know that if the metals are having the shiny surface, if the metals are having shiny surface, non-metals should have non-shiny surface. That is, they are non-lustrous. So metals are lustrous, non-metals are non-lustrous. Okay. Now here graphite. Okay, graphite, when you see the lead, okay, they are non-lustrous. The type of surface it has is non-lustrous. Then the hardness. Okay, graphite is hard. Usually it is hard. Malleability, no. Okay, so when you see the non-metals, okay, they are usually they are non-malleable, they are non-ductile, they are not hard. Okay, they are not hard. They are having non-lustrous surface. They are bad conductors of heat and electricity, and they are non-sonorous. Okay, whatever the properties we have studied of metals, it is vice versa for non-metals. If the metals are lustrous, non-metals are non-lustrous. If the metals, they are good conductors of heat and electricity, non-metals are bad conductors of heat and electricity. These are metals are sonorous, non-metals are non-sonorous. Metals are malleable and ductile. Metals are malleable and ductile. Non-metals are non-malleable and ductile. Okay, so like this, the properties are distinguished. Okay, so because of this categorization, the elements, they are categorized as metals and non-metals. So graphite, it is non-malleable, it is non-ductile, and it will conduct electricity. Yes, it conducts electricity. Sonority, no. Okay, few exception, but the general property is that they are no, bad conductor of heat and electricity. Then coal, where coal is used. Okay, so before, in the in old times or in ancient times, coal was used in engines, right? To run the to run the engine. Okay, coals were used. Now coal, it is also a form of carbon, right? So it is having non-lustrous, it has no shiny surface, they are hard, malleability no, they are not, they cannot be converted into thin sheets and not wires. So no ductility, it does not conduct electricity, and they do not produce any sound. Sulfur, next element is sulfur. They are also non-lustrous, they are not having any shiny surface. Next is what? They are not hard, they are not hard. Okay, then malleability, no, it cannot be converted into thin sheets, not they can be converted into thin wires. They do not conduct electricity, and they do not produce sound. So no sonority, no conducts electricity. Next is iodine. Iodine is a halide, right? It is a halogen. It comes under halogen group. So type of surface, it is lustrous, it is having shiny surface. They are no hard, it is not hard. It cannot be converted into thin sheets and thin wires, and it does not conduct electricity, and it does not produce sound. So generally, okay, to categorize the elements into metals and non-metals, so these are the few properties. Okay, so is it clear up to here? The properties, physical properties of metals and non-metals. Any doubts up to your students? If you have any doubts, you can ask me. Yes, any doubts? Okay, so let us go for the next one. Okay, so few elements. Now, if the elements, if they are having the property of metals, then they will come into metals. If they are having the property of non-metals, then they will come into what? They will come into non-metals. Okay. Now, there are few exceptions. Okay, there are few exceptions where metals. Okay, so there are some metals unlike the mercury. Do you know mercury? So these are mercury, all the metals, they are solid. All the metals, they are solid at room temperature. But this mercury, okay, this mercury, it is liquid. At room temperature is also liquid. So there are few exceptions. So there are few exceptions where such metals are present. Okay, where metals except your mercury, all are solid at room temperature. So mercury is liquid at room temperature. So this is what? This is the exception. Okay, remember that all the metals, they are solid at room temperature. The exception is what? The exception is your mercury. Okay, the mercury. Okay, that is liquid. Next point, metals have high melting point. Just now we have discussed metals have high melting point. But gallium and cesium, so these are also the metals which are having very low melting point. Okay, when you hold them on your palm, it will melt. Okay, when you hold these metals on your hand, okay, on the palm surface, these will melt. Okay, so metals generally they are having high melting point, but these two, gallium and cesium, the exception is that they are having low melting point. Okay. So next is what? Iodine. Iodine is a non-metal, but it is having shiny surface. Lustrous means what? It is having shiny surface. Okay, so these are few exception. Okay, some exception. Iodine is a non-metal, but non-metal does not have the lustrous property. But this iodine, it is having that lustrous property. That is, it is having a shiny surface. Next is carbon. Carbon is a non-metal, but it will exist in different forms. That is allotropes. Okay. So which are the two allotropes of carbon? Anybody knows? Anybody knows what is the two? Uh, which are the two different forms, or what are the allotropic form of carbon? One is the diamond. Okay. One is the diamond. Another is the graphite. Okay. Another is the graphite. So in detail about the allotropes, we are going to discuss in the chapter carbon and its compounds. Okay, so there I will discuss. So now I will just tell you. Okay, so there are two allotropes of carbon, diamond and graphite. Diamond is hard. Okay, graphite is soft. Diamond is having lustrous. Okay, it is having the shiny surface. Graphite is having, graphite is also what? It is also having a shiny surface. Okay, then these are the different properties. Okay, uh, so carbon, it is a non-metal, but it will exist in different forms. Okay, so you can see both are made up of carbon, but one is hard, another is soft. One is lustrous, another is non-lustrous. Okay, like this, the properties are different. So these are also few exceptions. Next is alkali metals. So which are the alkali metals? So when you see the periodic table to your left hand side, that is your sodium, lithium, sodium, potassium. Okay, so these are your rubidium, cesium, scandium. So these are all your what? Alkali metals. So lithium, sodium, potassium, right? So these are all what? We said that metals are generally hard. Okay, metals are hard, but there are few examples. Okay, like your lithium, sodium, and potassium. These are the exception where these are soft. Okay, these metals are soft and they can be cut with the help of knife. You can cut them. You can cut this element, these metals with the help of the knife. And they are having very low melting point and low density. The density is very low. That is, their volume by mass ratio is very low. Okay. So these are the physical property or and some exceptions, okay, of the metal. So here you can see the first one is your mercury. The first one is your mercury. So mercury is what? Mercury is, it is liquid. Okay, mercury is liquid. All the metals are solid except the mercury. You can see how it is liquidiform. This is your gallium. Okay, this is your gallium. So all the other metals are having high melting point. Gallium and your cesium. Okay, gallium and your cesium, they are having low melting point. Why they are having low melting point? You can see if you hold them on your palm, okay, it is getting melted, right? It is having generally low melting point. So these are the two exception. Then diamond, okay, they are having the shiny surface. Carbon is a non-metal, but it is having the shiny surface. So diamond, it is a allotrope of carbon. So this is also one exception. Then this is your sodium metal. Sodium metal, okay. Sodium metal, it can be cut with the help of the knife. It can be cut with the help of the knife, and these are soft. So metals are all hard, but the exception is that sodium is a soft metal. It can be cut with the help of knife. Is it clear up to here? Yes, any doubts? Any doubts? Yes? Okay. Okay. Next, we are moving to chemical properties. Next, we are seeing the chemical properties. Okay. Okay. Next is reaction of metals with oxygen. Reaction with of metals with oxygen. So just now we have discussed what is the chemical property. Chemical property means how it reacts. Okay, how it reacts with the other substance. Now let us see the metals. Alkali metal. What is alkali metal? Alkali metal is now when you see the periodic table. Okay, when you see the periodic table, to your left hand side of the periodic table. Okay, now in the as there are 119 elements in the periodic table, you cannot study each element separately. So the periodic table is divided into four groups. It is divided into four groups: S block, P block element, D block element, and F block elements. Okay, in that S block elements, there is two groups. Okay, that is alkali metals and the alkaline earth metals. Okay, alkaline earth metals. So alkali metals, which comes under alkali metals, the first row. Okay, lithium, sodium, potassium, rubidium, cesium. Okay, so these are the elements which come under alkali. Is it clear? Is it clear? Okay. So let us see what is the reaction of metals with oxygen. Now, metals. Okay, we are seeing the chemical properties of metals. Now, metals. How we will represent metal as M. Okay, non-metals. So metals, when it reacts with oxygen. Okay, in the atmosphere, what is present? Air is there. So air consists of what? Air consists of oxygen. So when you react your metal with air or oxygen, what it forms? It forms metal oxide. What it forms? Metal oxide. So the reaction is metals when react with oxygen forms metal oxide. It forms what? Metal oxide. Is it clear? So metals, when it reacts with the oxygen present in the air, it forms metal oxide. So by using this reaction, we can use different metals. So first I have taken copper. Let us take copper. So what I'll do, copper is there. What it is doing, it is reacting with the oxygen. Okay, in the air, oxygen is present. What it is going to form? It is going to form the copper oxide. Okay, it is going to form the copper oxide. Balance the reaction. We have seen in the first chapter chemical reactions and equations. Okay, how to balance the reaction. Copper is 1 here on the left hand side. Copper is 1 on the right hand side. Copper is 1. Oxygens are 2 and your oxygen is 1. So what I will do? So first I will balance the oxygen. Now your oxygens are how many? Only 1. So I will write 2. Okay, now oxygens are 2. Now oxygen is 2. Copper is also 2. Now this side copper is 1. Oxygen is 2. Now what I have to do? I have to balance the copper. So I will write 2. So is it clear? So balancing is very important. So copper, when it reacts with oxygen present in the air, it forms copper oxide. So this is black color powder it will form. So this is the copper oxide. Okay, copper oxide. Copper oxide. Okay, that is CuO. Cu is in +2. The charge is +2. So copper, when it reacts with oxygen, what it forms? It forms copper oxide. Okay, is it clear the reaction? Is it clear? Okay, let us go for the next one. Next reaction, next example, aluminium. Okay, aluminium. It is represented what? It is represented by Al. Aluminium is represented by Al. Okay, so aluminium reacts with the oxygen present in the air to form what? It forms aluminium oxide. It forms aluminium oxide. So Al2O3. Okay, Al2O3. So balance. So this becomes okay. So this is the reaction. Okay, this is the reaction. So aluminium, when it reacts with the oxygen present in the air, it forms aluminium oxide. So this white color powder, what you can see, it is aluminium oxide, and this is your copper oxide. Black color powder is your copper oxide, and this is your aluminium oxide. Okay, then silver, gold, platinum. Okay, these are also metal, but they do not react with the oxygen or air even at high temperature. So these metals, so there are few metals which do not react with oxygen. Why? Because they are least reactive. they are least reactive because of the property that is they are least reactive. They do not combine or they do not react with oxygen. Okay, even at the high temperature. So which are the metals? Silver, gold, and platinum. So these are the metals, okay, which will not combine with oxygen or air even at high temperature. Why? What is the reason? Because they are least reactive. Least reactive means they do not react. Okay. The property is that is they are having very less reactive property. Okay. Lithium, potassium, sodium. Okay. Lithium, the elements just now. Okay. We discussed what are alkali metals. Alkali metals, they are the group 1 elements. Okay. Group 1, that is which are present in the S block. That is your lithium, sodium, potassium. So these elements, they react vigorously. Vigorously means what? Very fast. Okay, they react very fast with the oxygen and they form respective oxides. And they form respective oxide. Lithium forms monoxide, sodium forms peroxides. Okay, Na2O2, Na2O2. Okay, so when lithium reacts with oxygen to form monoxide, sodium reacts with oxygen to form peroxide, and potassium reacts with the oxygen to form superoxides. Okay, so when the lithium, potassium, sodium, when they react with the oxygen, they react very fast. Okay, remember that lithium forms monoxides. Okay, then sodium forms peroxides. Sodium form peroxide and potassium form superoxides. Okay, potassium forms superoxide. Remember this, very important property. So these are the reactions of metals with oxygen. Is it clear? Is it clear up to here? Yes? Okay. Let us go for the next one. Reaction of metals with water. Okay, now metal is there. It is reacting with water. What it will form? What it will form? So metal, okay, hydrogen, H plus and OH minus. So metal, it reacts with the OH, okay, and it forms hydroxide. Okay, metal reacts with the water and it forms what? Hydroxide plus H2 gas is liberated. Plus H2 gas is liberated. OH twice and H2. Okay. So hydrogen gas is liberated or it is escaped out or it is escaped out. Is it clear? So what happens? What is happening here? Reaction of metals with water. So metals, they form hydroxide. Okay. Respective hydroxide and hydrogen gas is liberated. Okay. When it is reacted with water. So most of the metals, they do not react with water. Okay, so many metals, they do not react with water. So the alkali metals, so just now we told which are the alkali metal. The alkali metals like your lithium, sodium and potassium, they react fast. Okay, they react fast with water. Okay, so let us see the reaction. Let us see the reaction. Okay, so most of the metals, they will not react with water, but few alkali metals, okay, the like sodium, they will react vigorously with water. So let us see the reaction with sodium. So sodium is a metal, okay, it reacts with what? It reacts with the water. So what it will form? Sodium, okay, H and OH. So it form NaOH. So it reacts with this Na plus, so this become OH plus H2 gas is liberated. So this is the reaction. So sodium reacts with water to give you sodium hydroxide and hydrogen gas is liberated. Okay, and hydrogen gas is liberated. So this is the reaction. Next is with calcium. Calcium is what? Calcium is a alkaline earth metal. Calcium is a alkaline earth metal. So just now we said in S block element, there are two groups. One is the alkali metals, another is the alkaline earth metals. Alkaline earth metals. Okay, so sodium metal, when it reacts with sodium hydroxide, reacts, okay, and it liberates what? Your hydrogen gas. Similarly, let us take calcium. Okay, calcium is what? It comes under alkaline earth metals. Okay, calcium reacts with the water. Okay, and what is formed? It forms calcium hydroxide plus hydrogen gas is liberated. Okay, so calcium forms calcium hydroxide along with hydrogen gas and okay and heat. So when it reacts with water, is it clear up to here? Yes, any doubts? So we have seen two important chemical properties. One is the reaction of metals with oxygen. Another is reaction of metals with water. Is it clear? Okay. Next question. Next is reaction of metals with dilute acids. Okay, reaction of metals with dilute acid. So metals when they react with the dilute acid, metals when they react with the dilute acid, it forms respective salt. It forms respective metal, salt, and hydrogen gases liberated. And hydrogen gases liberated. Okay. So metals when they react with dilute acid, okay, metals when they react with dilute acid, they form metal salt plus hydrogen gases liberated. So let us see one example. Okay, metal we have taken sodium. Metal we have taken sodium. So let us react the sodium with a dilute acid. Let me take a hydrochloric acid. Dilute hydrochloric acid, HCl. What do you mean by HCl? Hydrochloric acid. So sodium, it reacts with dilute hydrochloric acid. And what it forms? It forms NaCl. It forms what? NaCl plus hydrogen gases liberated. Plus hydrogen gases liberated. Okay, so 2Cl. So this also should be 2. This also should be 2. So 2Na plus 2, that is HCl, okay, giving you 2NaCl plus H2. So what is forming? So when your metal, when it reacts with the dilute acid, it forms the respective salt. NaCl is a salt, right? Respective salt and hydrogen gases liberated. Similarly, one more example, let us take magnesium metal. Okay, next example is magnesium metal. So magnesium, again, take react it with hydrochloric acid. Okay, dilute hydrochloric acid, what is going to form? MgCl2. Okay, it forms MgCl2. Mg is plus 2. Cl is minus 1. So Mg plus 2, Cl is minus 1. So 2 and 1. So crisscross, what you are going to get? MgCl2. Okay, because magnesium is having plus 2 charge. So magnesium chloride plus hydrogen gas is liberated. So magnesium is a metal. It reacts with the dilute acid to form a respective salt. Okay, to form a respective salt, that is magnesium chloride, and hydrogen gases liberated. Okay, and hydrogen gases liberated. Is it clear? Okay. Next is reaction of metals with solution of metal salts. Reaction of metals with solution of metal salt. So what is happening here? There is a displacement reaction. There is a displacement reaction. Now let us see what will happen in displacement reaction. Already we have seen in the chemical reactions and equation chapter the types of reaction, right? Combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. Remember, recall. Yes. So in that, what we have discussed about the displacement reaction, the more reactive metal, okay, it will displace the less reactive metal. Okay. So what is happening here? So we have a metal A. With what we are going to do, we are going to react with the solution of metal, another metal. So we have taken the salt of metal 2. Okay, we have taken metal and we are reacting it with the salt of metal 2. Okay, so which metal I have taken? Let me take zinc. So zinc is a metal. It is a solid metal. So we are going to react it with what? We are going to react with a copper sulfate, aqueous solution of copper sulfate. So what is going to happen now here? Yes, what is going to happen? This zinc will combine with SO4. And what I am going to get? I am going to get zinc SO4, okay, aqueous plus copper solid. So what will happen? The more reactive metal will displace the less reactive metal from its salt. So you are going to get salt of metal A plus metal B. Okay. So this is a type of what type of reaction, students? Displacement reaction, right? It is a displacement reaction. Is it clear? Yes. Is it clear? Okay. So next is the reactivity series. Very important. Reactivity series. So in the reactivity series, it tells you the reactivity of a metal. So you can see on the right hand side here, right? The reactivity series of different metals is given. So this is the order of intensity or how it reacts, okay, of a metal. So this is termed as the reactivity series. So potassium, okay, which is at the top, it is what? It is the most reactive. Okay, it is the most reactive. Then sodium, then calcium, magnesium, aluminum, zinc, iron, tin, lead, copper, mercury, silver, and gold. So gold, silver, mercury. Okay, so these are the least reactive. So from down to above, the reactivity goes on increasing. So which are the highly reactive? Sodium, potassium, calcium, these are highly reactive, and least reactive is your gold, silver, mercury. Okay, so this is the order of reactivity of metals. So the reactivity of metals, what is happening? As you go down, it is decreasing, okay, from top to bottom. So so gold, silver, right? These are least reactive, okay, and potassium, sodium, these are highly reactive. Okay, so potassium is said to be most reactive and your gold is said to be least reactive. So this is the reactivity series. Reactivity series means how it reacts. Okay, how the reactivity takes place. Understood it up to your? Okay. Now, we have discussed about the metals and we have discussed about the non-metals. Okay. Now, how these metals and non-metals will react. Yes, how these metals and non-metals will react. We have discussed the metals and we have discussed the non-metals. Now, how do metals and non-metals react? So metals and non-metals, okay, they will react with each other. Okay. And what it will do, it will try to attain the noble gas configuration. Okay. Now, which are the noble gases? Yes, which are the noble gases? So if you see the periodic table, okay, if you see the periodic table again, okay, to your right hand side, okay, the last group, that is group 18, okay, are your noble gases. Okay, noble gases. So which are the noble gases? Helium, neon, argon, radon, okay, xenon. So these are the your what? These are all your noble gases. So what are these noble gases? Why they are called as noble gases? Because they have completely filled valence shell. They are having completely filled what? Valence shell. They are their octet is complete. Octet is complete means what? They have 8 electrons in its outermost shell. When they are having 8 electrons in its outermost shell, it is said to be a noble gas configuration, or it is said to be a completely filled octet. Okay. So so whenever any metal it reacts with non-metals, it will try to complete its valence shell. It will try to attain the noble gas configuration. Why? Because this is a stable. Okay, it is very stable. When you attain the noble gas configuration, then we say that the compound formed is the stable compound. Okay, so when metals and non-metals react, they should attain the noble gas configuration. What do you mean by noble gas configuration? Noble gas configuration means the tendency of an element to attain the noble gas configuration. That is, it should have the completely filled electron, 8 electron in its outermost shell. Okay, fine. So the remaining things, okay, about this we shall be discussing in the next class. So next we are going to see examples, okay, of a metal and a non-metal reacting. Any doubts up to your, yes, if you have any doubts, you can ask me, okay. So the same, this, okay, we are going to discuss in the next class. Any doubts up to your? So in today's class, what all we have discussed, let us summarize. Okay, so we have started with the chapter metals and non-metals. So what all things we have discussed? Firstly, we have started with the physical properties of metals. Okay, that is metals are having the shiny, that is lustrous property. They are hard. They are good conductors of heat and electricity. They are malleable. They are ductile, and they have the unique property of sonority, that is they are sonorous, that is it is they can produce sound. Then we have discussed about the non-metals. Okay, they are non-lustrous, they are bad conductors of heat and electricity, they are non-malleable, non-ductile, they are not hard, okay, and they are non-sonorous. So these are the properties of non-metals. Then there were few exceptions, okay, of these metals, okay, and non-metals. Then we started with the chemical properties, how the metals react with oxygen, how it reacts with the water, how it reacts with the dilute acids, and how it reacts with its metal salts, right? So these things we have discussed. Then we have discussed about the reactivity series, right? Reactivity series. And then we had started with how metals and non-metals will react. Okay, so the same we will be continuing in the next class. Okay, I hope there are no doubts. Yes, any doubts you can ask me. Okay, fine. I hope there are no doubts. Okay, so the same will be continuing in the next class. Thank you. I'll end the session here. We'll meet in the next class. Thank you.